Good morning, students. Today we are going to discussing about current and current and electricities. So current means the flow of charges in a circuit is known as the current. It means in a circuit some of the charges are moving. These charges may be positive charges or negative charges. Sometimes ions also behaves as a charges. Ions means nothing but the positive atoms or negative atoms. So in SI units, the current in SI units, the current have amperes. So next one is the electricity. So there is a two definitions for electricity. One is it is a one of the energy which can use to make a light or heat and some extra energies. So another definition is it is a physical phenomena will observe when the matter is in motion which have some charges in it is known as the electricity. In simple units, the units of electricity is kilowatt hour. So that is the definition of current. So in SI units, the current have amperes. So for electricity, in simple units, we have kilowatt hour. That is the definitions of current and electricity. So in this chapter, we will learn what are the basic laws for to study current. What is meant by study current means the intensity of current does not change with respect to time is known as the steady state current. So first, what is the electric current? What is the value of electric current? So now here you are deriving some equation for the current. Let's take a area. So in this area, some of the positive charges moving forward and also some of the negative charges also moving forward. Okay, so then the net charges in a area is Q plus minus Q minus. Here Q plus is the positive charges and Q minus is the negative charges. The resultant gives the total charges. Now the current in that area is gives the ratio of charges by the time. Here I is the current and Q is the net charges and T is the time. Suppose if this value gets positive means the current direction is positive forward direction. Suppose if this value gets negative, the current means backward direction. Positive means forward direction and negative means backward directions. Every time the current may not be steady. Sometimes it will be changes with respect to time. So for the change of current, what is the equation? Let's take a same area. Let's take a same area. The resultant charges is delta Q. So these net charges is moving in the time interval that is a T and T plus delta T. Sorry, this is delta T is the net charges in a area. These charges flowing with the time between T and T plus delta T at any time. You don't know the time. So at any time T, the current in that area, the change in current in that area, that is equal to, so delta I is equal to limit T to 0 delta Q by delta T. So this is the change in current equation. So this is the steady state current equation. This is the change in current equation. So you know that the current will measured in amperes in SI units. So that is the electric current. So now next one is the electric current in a conductor. So here the main aim of this topic is how we can get a steady current in a conductor. So normally, depending upon the conduction, the metals divided into three types. So one is the insulator, and the second is the semiconductor, so third one is the conductor. So when current will flow, when the circuit have some free when the circuit have flow of charges, then we can get the current. So in the insulator, every electron will bound with atoms. There is no free electrons, so there is no current in the insulator. In the semiconductor, only few of the electrons are free, so then we observe some small current in semiconductors. In the conductors, there are a number of free electrons, so then we will see we will observe the current in the conductors. So here, for example, the insulator example is glass and rubber. So for the semiconductor, we know that there is a silicon and germanium. So for conductor, so there is a iron is the best example. So insulator means there is no free electrons to carry the current. So that's when there is no current in the insulator. For example, can't observe any current in a glass and rubber. In a semiconductor, so there is a few free electrons, so we will see the small current in a semiconductor. So example is silicon and germanium. Next one is the conductor. There is a number of free electrons to carry the current in a conductor. The best example is the iron. So first here you are observing the steady current in a conductors. So conductors also so many types. For example, solid conductor and electrolyte conductor. In a solid conductor, every atom bound with each other atom. So in this conductor, the electrons will carry the current. In the electrolyte, the positive ions and negative ions carry the current. So for that we observe the current with positive ions and also negative ions. But we will discuss only about the conductor. So let's take a cylinder having two ends. The radius is capital R. Radius is a capital R. So in this conductor there are ions and also some electrons are there. Ions means positive atoms or negative atoms. So here, due to the thermal energy, the electrons will move in the conductor. When the electrons moves in the conductor, these electrons will collide with the ions. Then it moves in a different directions, nothing but the random direction. Then the net current will become zero. Net current will become zero because the electrons moves in a different direction, so not moving in the same direction. For that, so the net current will become zero. So let's take two plates. That is a positive charge plate and a negative charge plate. Positive charge plate place at one end and negative charge plate placed at one end. So due to these charge plates, some of the electric field will develop inside the conductor. Some of the electric fields developed inside the current. It means some of the current will flowing inside the conductor. So after that, when the electric field is formed, the electrons, that is nothing but the positive charges move towards the the negative charges will move towards the positive charges, then combine each other will become neutralized. After that, the electric field will become zero. So here we are observing only the small current in a small time. So not observing the steady current, it is not a constant current. So if you want to observe the steady current means, so apply the any batteries at two ends, then we observe the steady current in the conductor. So this is the result. So when you observe the steady current means when you apply the electric field continually, we will observe the steady current in the conductor. So that is the electric current in a conductor.